Factor the following polynomial given that it has a 0 at 10 with multiplicity 2. Okay, so we have this quartic polynomial. Because it's quartic, it's going to have 4 separate zeros. So we need to get this written in a set of linear factors so that we can identify what those zeros are. But we've already been moved along in the process a little bit. We know that we've got zeros of 10 2 times. So what that means is I can factor out the first 0 of 10 using synthetic division. We'll just take this into the coefficients 1, negative 13, negative 34, 580, and 600. And the result after using synthetic division should give me 0 here as my remainder. So let's see. Bring the 1 down. 1 times 10 is 10. This is negative 3. Negative 3 times 10 is negative 30. These add up to negative 64. And if I multiply 10 times negative 64, that's negative 640. And that adds up to negative 60. And when I add or multiply 10 times negative 60, that's negative 600. And that actually does add up to 0, which is perfect. So these are the coefficients of a cubic polynomial. Because this is a constant term, this term is multiplied by x, this term is multiplied by x squared, and this one by x cubed. So what I need to do then is figure out what the remaining polynomial is if I factor out 10 from the cubic. So 10 factored out from this cubic polynomial of x cubed minus 3x squared minus 64x minus 60. Let's see what happens. Bring the 1 down. 1 times 10 is 10. This adds up to 7. 10 times 7 is 70. That column adds to 6, and 6 times 10 is positive 60, and we would get a result of 0. So now, what this means is this polynomial function has now been factored into x plus 10, well, actually, be careful there, x minus 10, because the 0 is positive 10, so the factor is x minus 10, times another factor of x minus 10, which I could more easily represent with x minus 10 squared. That's what's meant by the multiplicity 2. And the remaining factors and the remaining quadratic, this is a set of coefficients of that quadratic where this is the constant, this is times x, and this is times x squared. So I have x squared plus 7x plus 6. My job now to find the remaining zeros is to just figure out what the zeros of this quadratic are. So with any luck, we should be able to factor this. Let's see what happens. Since the leading term coefficient is 1, all I need are 2 values that multiply to 6, then add to 7. So positive 6 and positive 1 work great. So that gives me the remaining factors, and from the factors I can identify all the zeros or express the polynomial in factored form, which would be x minus 10 squared times x plus 6 times x plus 1.